This is section 10.1, part B, sequences, series, and sigma notation. In lesson 1.3, you examined the end behaviors of graphs of functions. You learned that as the domains of some functions approached infinity, the ranges approached a unique number called the limit. As a function, an infinite sequence may also have a limit. If a sequence has a limit such that the terms approach a unique number, then it is called convergent. If the sequence does not, it is called divergent. So basically what this is telling you is if the values for your y value get closer and closer to a specific value, the larger your x value gets, then this would be convergent. And if they are not approaching a specific value, then it would be called divergent. So we're going to determine if each sequence is convergent or divergent. To do this, we're going to examine the values for the function. So you can make yourself a table. Now, if you don't want to do all of these calculations by hand, you can put it into your calculator. You can go into your y equals. So if we find our graphing calculator, if we go into our y equals, we can put in negative 3x plus 12, and then we can go back to our home screen. Now if we go to our table, to do that you'd hit second table, and it's going to show you the values. So we're going to start on the first term, and we can write down what these values are and see what they're approaching. So in our table, if n is 1, we have an a sub n of 9, 2 is 6, 3 is 3, 4 is 0, and if you notice, these values just keep getting smaller and smaller. They're not approaching any specific value, so that means that they are divergent. Again, for the next one, you will have to do this one by hand because this is not an explicit formula. So up here, this was an explicit formula. It just said n. Down here we have a recursive formula because it says you have to take the previous answer. So you cannot put that in your calculator. You will have to do this one by hand. And we know when n is 1, our a sub n is 36. So at 2, it says we're going to do negative 1/2 of it. So we're going to multiply 36 by negative 1/2, and that's going to give us negative 18. For 3, again, we're going to do our previous answer times negative 1/2. So negative 18 times negative 1/2 will give us a positive 9. 4 will give us a negative 4.5. At 5, we're going to be at a positive 2.25. 6, we are going to be at a negative 1.125. For 7, it'll be a positive 0.5625. And at 8, we will be at a negative 0.28125. Now, if you notice, we're jumping from a positive number to a negative number. So we have one up, then the next one's down. Then we're up and we're down. But these values are getting closer and closer as they alternate between positive and negative to the value of 0. Since these values are getting closer and closer to 0, this would be convergent. For the next one, because this is an explicit formula, it just has n's, it doesn't have any a sub n minus 1's, you can put this directly into your calculator. And for 1, we would have negative 0.2. 2, we're going to have 0.22. 3 is going to be negative 0.23. 4 will be a positive 0.235. 5 will be at a negative 0.238. 6 is at a positive 0.24. 7 is at a negative 0.241. And 8 will be at a positive 0.242. So this one is alternating between positive and negatives, but those values, the negative values, each time are getting a little bit larger, and the positive values are each getting a little bit larger. So they're not actually getting closer to a value, they're getting farther away from each other. So this one would be divergent. A series is the indicated sum of all the terms of a sequence. Like sequences, series can be finite or infinite. A finite series is the indicated sum of all the terms of a finite sequence, and an infinite series is the indicated sum of all the terms of a finite sequence. So if our sequence is finite, and it's 1, 2, 3, 4, 1, 3, 5, 7, and 9, for your series, you're just going to take those terms and you're going to add them together. Same for an infinite. If you have the terms, you're just going to add them together, but you will never be able to get a complete answer because it is infinite. The sum of the first n terms of a series is called the nth partial sum and is denoted S sub n. The nth partial sum of any series can be found by calculating each term up to the nth term and then finding the sum of those terms. So we need to find the fourth partial sum of this series. So we first need to find the first 4 terms. So this will be negative 2 plus 3, which gives me 1. Next, we'll do negative 2 squared plus 3, which will give me negative 2 squared is a positive 4, plus 3 gives me 7. And you would do this for all of the terms. So this will give us a negative 8 plus 3, which will give us a negative 5. And this will give us a positive 16 plus 3, which will give us 19. So to find that partial sum, you're going to take those values and we're going to add them all together, and it should give you 22 as your partial sum. For the next one, we're going to find the sum of the first 3 terms. So for our first term, we're going to have 4 over 10 to the first. The second will be 4 over 10 to the second. The third one will be 4 over 10 to the third. Now this would be 4 over 10 plus 4 over 100 plus 4 over 1,000. Or we can write that as 0.4 plus 0.04 plus 0.004. And that's going to give us a sum of 0.444. Series are often more conveniently notated using the uppercase Greek letter sigma. A series written using this letter is said to be expressed using the summation notation or sigma notation. So in sigma notation, if you see this symbol, the number underneath is going to tell you where to start in the series, and the number on top is going to tell you how far you need to go, so how many terms you need to do. So we're going to find the sum. This tells me I'm going to start on the first term, and I'm going to do the first 5 terms. So we would do 4 times 1 minus 3 plus 4 times 2 minus 3, and we would do this for the first 5 terms. And if you do this by hand, you should get a value of 45. Now, on your calculator, you can find this if you hit the math button, which is right underneath of alpha. We can find the summation. It is option 0, so we can do summation. and then it's going to let you put in the values. So we're going to start where x is equal to 1. We're going to go until we get to 5, and then we're going to put in the equation that we just did. So it'll be 4x minus 3. And if we hit enter, it will give us the value of 45. So you can find these if they are explicit formulas on your calculator. Now on this one, again, it's going to tell you where to start and where to end. So we would start, if we did this one by hand, at the 3rd term, and you would go until you got to the 7th term. So we would do 6 times 4 minus 3 all over 2, and you would do this until you got to the 7th term. If you put this into your calculator, again, you would hit math, you would go down until you find summation. We're going to do x starts at 3, goes to 7, and our equation, if we hit alpha y equals, it's going to let us do a fraction on your normal calculator if you have the 84s. But if you don't, you can just put it in as parentheses. So we can do 6x minus 3 divided by 2. So we have that numerator in parentheses. And we should get a value of 67.5. Now on the next one, if you notice, this has an infinity symbol on the top, so it means you need to add all the values together. If it's an infinity, you cannot put this on your calculator. So we would do 7 over 10 to the first, plus 7 over 10 to the second, and you would do this for all terms. Now, we just need to see what's happening. So this is going to be 7 over 10, plus 7 over 100, plus 7 over 1,000, and this would continue on forever. If we write these as decimals, that's going to give me 0.7 plus 0.77, 0.07. So if we add those all together, it'll just be 0.777 going on forever, or just be 0.7 repeating, which you can also write as 7 over 9.